Welcome to Ask Jerry and Ray Anything about IBM Z. Today, we're going to talk about
What is IEBGENER? So first we're going to talk about what it is, where it came from, and how to use it. And then we'll go into a little bit more about how it actually does things and the JCL structure. We'll talk about some of the DD statements that are important for this program. We'll talk about the sysin parameters, which you'll find out are actually kind of optional depending on your use of it. And then we'll talk about use cases. So to start off, what is IEBGENER? Well, we've already asked that question, so let's go ahead and answer it. Well, it is an IBM system utility. It's provided with the operating system. No need to install anything extra to get to it. And its primary use is copying sequential data sets or PDSs or even just members of a PDS from one location to another. This can be from a sequential to a sequential, from a sequential to a partition member, from a partition member to another member, or the entire partition data set to another partition data set.
Yeah, but you'd have to do that a member at a time.
Oh, that makes it a little bit more ugly.
Yes. If you want to do the whole thing, you got to use IB copy, which might be our next topic.
Yep. So IEBGENER is part of the Data Facility Utilities, which is a mouthful to say for some reason. Hello, Sarbanes. Yes, thank you for your gracing us with your presence. Come on. No. Yes, lay down. Dealing with cats is so much fun. So, IEBGENER is part of the Data Facility Utilities, which is a mouthful. Program name is IEBGENER. It's found in sys1.linklib, and as we said, it's available on every single version of ZOS. Well, starting with OS 360 back in the 1960s. I would hope that you're using a newer version by now. But yeah, it's one of the most widely used utilities in the mainframe, which is partly just because it's reliable and it's simple. So this is kind of the overview of the ZOS, inverted ZOS stack and where to find IEBGENER. You have the operating system as your core component, the data facility utilities, which is a subset of programs where you can see down at the bottom there some of the other ones. As Jerry mentioned, you got IEB copy, IEB update, IEB comper for compressing things, IEB PTPCH, which is your print punch. You can actually print things using utilities. IEB edit, if you want to edit JCL on the internal reader or save it off, and then IEB image, if you actually want to print images. And people say that ZOS is boring. So, as I said, the primary functions of IEBGENER are copying data sets from one place to another, and you got your sequential data sets. You can convert it to a PDS member. You can reblock a data set. So if it was allocated a long time ago and you're now using a different architecture of storage, you can reblock it so it's more efficient. You can edit during the copy, so while you're copying it from one place to another, you can make some replacements and updates. And again, you can create PDS members from You can create PDS members from a sequential data set. And you can print the dataset contents if you actually set your output dataset or the output DD statement to a printer. And so here's kind of the general flow of the program. You have your JCL being submitted, exec PGM equals IEBGENER. You got your sysin parse statement, or you got your sysin statements, which kind of tells the program additional things of how you want to run the program, additional options. Sysut1, which is your input data set. You open that up. You process your records, copy, edit, reblock, what have you. You write them out to the Sysut2, and then you get your output from the functions in your sysprint. Were we skipping the JCL?
No, this one is good. This one is
Okay.
actually correct for a change.
Okay. So this is an example of the simplest you can get with IEBGENER using a copy. So as you see here, the sysin is a DD dummy. It means we don't have any special sysin statements. You've got your sysut1, which is an existing data set. Then your sysut2, which we're writing it out to a new data set. And we've got some different parameters in there. But if you want to do... Wait, no, is that on the next? No, I thought it was on the next slide. And you've got your sysut2, which is a new data set. And if you want to use the same DCB information from sysut1, yeah, you can probably just leave that off of sysut2. Isn't that right, Jerry?
That's correct.
Okay. Yeah, so this could get a little bit simpler just by ignoring, omitting that last line. But, sometimes you need to change things a little bit. And again, the DD statements that are required for IEBGENER. You've got your sysut1, which is the input data set, sysut2, which is your target output. And again, this can be a data set, it can be a printer, it could even be the spool file in JES. You got your sysprint statement, which is your logs for the utility messages, and then sysin, which are your optional control statements. Even though they're optional, the DD statement's required. So if you don't have anything, DD dummy. Diving into these a little bit deeper.
It's my turn now.
Oh boy.
So Ray and I agreed to have some dramatic conflict. So he said that IEB COMPR was IEB compare, but he actually knows is IEB compress, but he actually knows it's IEB compare. But see, that way we have this conflict, and I correct him, and he glares at me, and we have excitement in our show. So, but we're gonna start
I've ruined
talking.
the drama.
We're going to start talking about the data sets a little bit more in depth. So your 6UT1, and one thing I want to interject here, I always felt like, okay, fine. If I don't have anything to tell you, then I don't need to have the sysNDD statement. I can leave it off if I don't have anything to tell you, but I have something to tell you, I can give it. IEBGENER, I guess, is so old that they just said, look, we're going to have four data sets. I mean, four DD statements. You got to give them to us all. If you don't need one, you can say DD dummy. If it's not there, we're not going to play. So, all right. So that's just to clarify what I think should be done and what IBM has actually done. So your 6UT1 data set, as Ray has said, it could be a sequential data set. It could be a member of a PDS, or it could be a PDS. But if it is a PDS, you have to specify member statements in your sysin. So, you can't copy, IB copy is the one that says, okay, I've got this PDS over here. I want to copy it to this new PDS. And it just goes and copies everything like that. This way, you'd have to copy each member one by one, which, if you only have 5 members, not that big a deal. If you got 285, probably not so much fun. And it's
Repeat and
the
update.
record format. Go back. I'm not. The record formats it supports are fixed block, variable block, and undefined. So you can use it on load modules. That's the primary undefined format. And it uses QSAM, and BSAM is used for its PDS processing. So we talked a little bit about QSAM, BPAM, BSAM, and they really are just the ways that uh, ZOS actually processes the data that it is working on. And you can concatenate multiple input data sets. So that if you have like 5 data sets you want to put into one data set, just stick them all together and send the output to sysut2, and then everything will be in that one data set. And speaking of sysut2, let's talk about what sysut2 actually is. That's your output data set. It can be new, it can be old, it could be mod, which means, okay, I don't want to overwrite everything. Old overwrites it. Mod says, this is an existing data set, but I just want to append stuff to the end of it. And share is shared access. It's just like old, except that you should be the only person who has it when you're actually executing that IEBGENER. And then the DCB parameters, we've talked about those as fixed block, variable block, etc., or just fixed or variable. You give it the record length, the block size, and as Ray mentioned, if you don't have a DCB parameter, then it's going to copy that information from sysut1. So you can specify it, but if you don't specify it, it's going to be the same as the input data set. All right. So that moves us on to sysprint. So of course, sysprint gives you your messages. And you expect that since you're such a wonderful programmer, you'll always get a condition code 0. But sometimes, occasionally, you'll get non-zero return codes. You get return code 4 is a warning. Something wasn't quite right. It still went on and did the job, but this is something that I didn't like, and IEBGENER is just telling you, I didn't like this. I'm not happy about it, but I'll go ahead and do the job anyway. Return code 8 is, oh no, this is wrong. I'm not doing this. And you need to check your DD statements and your input data. Something in there is not quite right. You got to fix it before I'll actually, and I being IEBGENER, will actually cooperate with you. Return code 12 and 16 are even worse. Not only is it an error, 12 is a severe error. That's it. Now, I'm not doing this. Check your JCL, get your act together, and come back and try it again. And then 16 is the same kind of thing. Something bad happened. It might not have been your fault, but something bad happened. So you need to check out your system and see what's going on. Let's say you got an IO error. It would say, well, I can't handle this. It's an IO error. I'm gonna give you return code 16. You go figure out what happened, get it fixed, and come back and try it again. And then we get to sysin. So we've got our output sysin, and it was a long time before I knew there were actually any statements for IEBGENER, because all I ever did was just straight up copies. And I learned that, oh, you can do things with this. So you can specify generate, and then you tell it what the record looks like. You can specify member. You can specify exit. So you can write an exit for IEBGENER to come in, and it allows you to come in and do whatever it is you decide to do in that exit for IEBGENER.
Oh, so
So
it's
let's
not
talk
like
about those
actually
statements.
creating like a, I want to exit the processing at this point. It's like actually injecting more code.
Exactly, exactly.
Okay.
And it's just like the exits that we have in Easy Exit in our Precisely product. So let's talk about these control statements. Let's go into some detail. Generate, you say I've got this number of fields, the maximum number of fields that I can have, the maximum number of literals, the maximum number of groups. These are, I'm sorry, maximum number of ident parameters, and the max number of names. So these are all the specifications that you can specify. And the generate statement says, okay, I'm going to specify these things, and this is going to happen in such a way that you will be happy. If you say the maximum number of fields I can have is 2, and then turn around and try to specify 3 fields, it's going to say, wait a minute, you lied to me. You told me you were only going to have 2 fields. You've got 3. It stops and says, you probably get a return code 8 that I'm not doing this until you tell me the truth. So that's what these maxes are for. It limits the number of specifications you can make. And these specifications are made on the record statement. So we come to the record statement, and we can specify a field, and it says I've got a field that is this long. I want this to be this long. I want it to start here. I want to convert it to um, some format. You can specify it to something like pack decimal or zone decimal, and then you tell it where you want to put the output. Ident says I want you to check for a specific value, and if it is this value, I want to go ahead and process it. If it's not, then I want you to leave it alone. You just copy it into my new member. I'm sorry, I'm a new member or the CQT2 output. So if we do a deep dive into the field, length tells you the number of bytes in the field. And then, of course, the input location tells us where it starts. And then the output location, you notice I skipped over conversion. The output location tells me where you want to put put this field in the output record in the CQT2 part. And then the conversion is a data conversion thing. So I can change from packed to zoned, from zoned to packed, or I can specify nothing and there won't be any conversion. So whatever the data is coming in, it'll be the same data going out. So
You'd kind of hope that, if you have a literal string field or whatever it is, it would be able to tell how long it is, but I guess you still have to tell it, my literal is this long.
no, actually, you don't have to tell it the length of the literal if you have a
Oh,
literal field.
okay.
So if you're trying to stick a literal in there, you don't have to tell it the length. It doesn't have an input location, so it's comma, comma, and then the literal and where you want it to
Ah,
be.
okay.
So so it's just, just makes life exciting trying to conform to what IEBGENER wants you to do. But that's what manuals are for, and AI, if you can get it to stop drinking long enough to give you good answers. All right. So if we move on to member, this is when we have a PDS. I've got a PDS, and you tell it, I want to copy this member. And oh, by the way, this member has some aliases. I want it to be, it's got alias one, alias two. And so I can say, I want to copy this member. I want to give it a name of Jerry. And then I put a comma, and I want it to be Jerry alias or JER alias, then comma Ray alias. Whatever aliases I want to associate with that member, I can specify those aliases in the member statement. And so this gives you more exciting information if you want to read that. So these are the exits: the input header exit, the input trailer exit, the output header exit, and the output trailer exit. And so these shows you when these exits are called. It calls after the input data set is open, but before any records are read. That's the input header. And then, the input trailer is after the last input record is read, and you can clean up, do whatever you need to do, which is always a good thing. Then you have the output header after the output data set is opened, and use the right header records or perform setup. And then the output trailer is the analogous exit to the input trailer. Okay, it's all done. The output data set is closed. Let me clean up my processing, and life is good. So those are your exits. And so Ray's going to tell us about common use cases.
Yep. So common use cases, real good use for them. Back up and restore a data set. It's just real easy to make a copy of a data set, especially if it's a very important one that you want to make sure you have. You can trust HSM to make a backup of it, but you can also just make another copy of it, just in case. Make sure it's on a different Volseer, what have you. Data migration. If you want to move a data set from one volume to another, storage tiers, you can move it to tape. You can move it to tape, yeah. Yeah, just make an output using a tape unit. It's just like making any data set. And format conversion, as we said, take it from, being a data set that, the block is this big and make it a bigger block, make it a smaller block. That might truncate your data. So you got to be a little bit careful with that. You can make reports.
It won't truncate the data.
Oh, well.
Changing the L record might truncate the data,
Oh,
but
yeah.
changing the block size just, gives you little teeny tiny blocks, and that's not good for performance. But it says, okay, that's what you want. That's what you can have. So
Yeah, that's right. It's the L record that'll truncate the data because that's how long each line is. Not. Yeah, sometimes I get those mixed up.
no problem.
And you can make some reports. And again, you can copy the data set and write it out to a printer. You can write it out to a sysout for pickup by a spool writer later. And there's lots of things you can do with it. The PDS management, taking a sequential data set, putting it into a member of a PDS, or you can do this for your source code, your JCL statements, a lot of different things. And then transforming data, you can actually move fields around within a data set. If it's, a very structured data set, you can move things around. You can insert literals, and convert data formats. Yeah. And kind of,
if you could go back, Ray, the data transformation, I can hear everybody saying, "Oh, but I can use that. Use an editor for that. I can go into ISPF edit and make these changes." Well, if you got if you got a data set that has 200-300 records, yeah, no big deal. If you got a data set that has 47,000 records, you may have some issues. You may run out of storage. ISPF edit will say, "Oh, this is too big. I'm going to change it from edit to browse." So even in our new wonderful environment, IEBGENER can get you out of trouble if you have something like that you have to work on.
yeah, sometimes doing things in batch is a lot easier.
Yes.
Yeah, one of the things actually I didn't see on here is going back here, compressing a data set. I know we have IEB compress, but IEB comper, but hey, there's tricks.
Yes, but you can't compress it in place. You have to compress it by copying it to another, by member copying it to another data set. That's the only way you could
I was just have
accomplish compression.
sysut1 equals sysut2.
No, that's only IB copy.
That's IEB copy. Aha. Okay, never mind. I'm getting
See, I
my
told you
utilities
we
mixed up.
planned this discussion, so we have something to talk about here. So
I get it. Yeah, it's still all sorts of things you get messed up even after quite a few years in the field. That's why I have it in my JCL library.
yes,
If I need something, I just go find it by member name. Yeah, so here's a comparison of these IEB utilities and some of the other utilities like IDCAMs. If you're doing sequential PDS copies, field editing, VSAM support, you can just look at this table to find out which utilities can be right for your use case, and go ahead and find the JCL examples. But for today, these are this is what we talked about, and yeah. So what do we have? What do we have coming up next, Jerry?
Well, we're gonna keep you guessing because we're guessing too, but we'll we'll have something hopefully that's interesting and of use to you. Um, don't forget to subscribe, hit the like button, and hit the bell so you can get notifications of when we have a new um, YouTube video. And until the next time, thank you for visiting with us.
Yeah. And if there's something you want us to talk about, put it down in the comments. Otherwise, yeah, who knows what's next?